about superposition principle. And in superposition principle, if one possible state of an ensemble of a wave is described by a wave function, say psi1, and another state of this same function of the ensemble is described by a wave function psi2, it means that for every linear combination we have psi equal to C1 plus C2 psi 2. Here C1 and C2 are constants, which also denotes the wave function psi1 and psi2 respectively. For example, if we consider a bullet, let's say this is a point that have two openings or two holes as the case may be, and then from this point I projected a bullet going to this point and this point. It is a single bullet. Since we have two holes, let's say O1 and O2, and I project a bullet from this point, there are tendencies that the bullet might enter through this O1 or it might go through this O2. So that is to say, let's make an assumption. When O1 is open, and then this will refer to two classes. We have a classical mechanism and we also have the quantum mechanism. We are actually addressing quantum mechanism. But from this example, classically, when O1 is open, we call it, or let O1 open to be equal to A1, let O2 open, we call it A2, and when both holes are open, we call it A1 plus or minus A2. And this happens when we talk about classical mechanism. But in quantum mechanism, we say let O1, or when O1 is open, we call it A1, and this is a pure state. The pure state. Also, when O2 is open, we call this also a pure state. And then when both states are open, we call it A1 plus or minus A2, and this is called a mixed state. What we are trying to say in quantum mechanics is that this A1 and A2, which we call the mixed states, they are independent of each other. That's very important. If we want to demonstrate it using what we call the Kate and the bra. Kate and the bra, this is what we call the Kate, and this is called the bra. How do we demonstrate it? This is a formation of a Kate. From the right, we have that is a Kate. We also have this to be, you can call it Kate vector. We also have this to be bra vector. Now, if I were to make illustrations, that's what we call the juxtaposition. And in juxtaposition, we say, for instance, given that in juxtaposition, we say, given that this and a bra given that a cat and a bra vector is given this, it means that when we multiply through this, if we play around with this, we have a C1 B prime 1 plus C2 B prime 2 is multiplied by that. The result of this expression becomes, if this multiplied by this, the result of this expression becomes C1, the combination of that juxtaposition, the combination of the kets and the bra. By the time this clears the bracket, that's C2 into B1 and B prime 2, and we have this to be A1, and we close it. This is the result we have, and this is called the juxtaposition.